Composition of functions. To get started, here's your state standards. Not too many today, that's good. And success criteria. You need to be able to evaluate a composition of functions, find a composition of functions, and state the domain of a composition of functions. There is one new vocabulary term today, composition. The composition of a function g with a function f is h of x equals g of f of x. The domain of h is the set of all x values such that x is in the domain of f and f of x is in the domain of g. All right, so what does that all mean? Basically, you're going to take one function and you're going to input it into the other function. So you're going to perform that operation. So this is called a composition of function. And you can see here where it says the domain of f and the range of f. So basically you input x into f, it comes out, and then you input it into g. And so basically you're putting a number into two different functions. Again, composition of functions, this is read g of f of x. So g of f of x. So this probably sounds a lot more confusing than it actually is. Once we look at a couple examples, hopefully you'll see that it's not too bad. Example 1, evaluating compositions of functions. Let f of x equal the square root of 2x plus 1 and g of x equal x squared minus 4. Find the indicated value. So I'm looking for g of f of 4 for the first one. So the first thing I'm going to do, I'm going to find f of 4. So you can see f is the inside function. So that means I'm going to apply this to f first. So let's go ahead and say f of 4 equals the square root of 2 times 4 plus 1. So I'm going to have the square root of 8 plus 1, which is 9. The square root of 9 is 3. So f of 4 is 3. So now we need to find g of f of 4. All right, so since we already have substituted 4 in for f, now we're going to substitute 3, that's our output, into g. So g says x squared minus 4. So we're going to do 3 squared minus 4, or 9 minus 4, which is 5. So g of f of 4 is 5. So it's pretty much, it's like a two-step process. So you're going to take 4, you're going to plug it into the first function here, take the output and plug it into the outside function next. All right, B part says f of g of 2. So again, we're going to start with the inside function. When we're working with composition of functions, we start with the inside function. So we're going to start with g of 2. So g is x squared minus 4. So 2 squared minus 4. 2 squared is 4. 4 minus 4 is 0. So then we're going to take 0 and plug it into f. So that's going to give us f of g. F of g of 2. So this part's a little bit confusing, but we are going to take the output of g and plug it into f, and then that will give us this expression here. So f of x says the square root of 2 times 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. The square root of 1 is just 1. So f of g of 2 equals 1. So once again, you're going to take 2, plug it into g, take 2, plug it into g, get the output of 0, and then take 0, the output, and plug it into f. When I do that, that means I found f of g of 2. So it's a two-part process, pretty much. So the last one says g of negative 2. So we're going to use the same function twice, but we're going to start with plugging in g of negative 2. So we've got x squared minus 4. Negative 2 has to be in parentheses since we're squaring that. So negative 2 squared is 4. 4 minus 4 again is 0. And then I take 0 and plug it into g again. So this one, g of negative 2. But I'm actually going to take the output here and plug it into the function again. So I've got x squared minus 4, but this time I'm going to plug in 0 squared minus 4. 0 squared is 0, and then minus 4 is just negative 4. So g of negative 2 would equal negative 4. All right, here's a note to remember in reading. It says, as with subtraction and division of functions, you need to be aware of the order of functions when they are composed. In general, f of g of x does not equal g of f of x, so the order does matter. Remember, you always start with the inside function first and then work your way to the outside. Example 2, finding compositions of functions. Let f of x equal 5 times x to the negative 1 and g equal 3x minus 3. Perform the indicated composition and state the domain. So the first one says f of g of x. That means we're going to take g of x and plug it into f of x. So we're going to have f of g of x. So we're going to take all of this and substitute it in for x here. So we're going to have 5, and then put this in parentheses, 3x minus 3 to the negative 1 power. And we know when you have something to the negative 1 power, properties of exponents says you move it to the bottom. So we're going to have 5 over 3x minus 3. So everything in parentheses is raised to the negative 1 power, which means it gets moved to the bottom. Again, that's per properties of exponents. B part says g of f of x. So since f is on the inside, we're going to work with it first. So we're going to take f and we're going to substitute it into g this time. So we're going to take this function here and we're going to plug it into the x value here. So we're going to start with g of f of x equals, and we're going to start with this function here, and in place of x we're going to put all of f. So 5x to the negative 1 power, and then we had minus 3 was already there. All right, so I can use associative property to regroup the numbers together. So 3 and 5, x to the negative 1, and then minus 3. So that's going to be 15. And then again, x goes to the bottom because it has a negative exponent. And then minus 3 is just still part of the equation. So I'm going to have 15 over x minus 3. So that represents g of f of x. C part says f of x. So we're going to take the same function and input it into itself. So let's start with f of x. And then I'm going to have 5. And I've got x to the negative 1. But I'm going to input that 5x to the negative 1 in place of my x. So I'm going to put 5x to the negative 1, and then I still have the negative 1 inside of here. So it looks a little bit funny. Let me rewrite that 5 here. So basically I took this function and I substituted the same function in place of x. So I've got 5x to the negative 1, and in place of x I've got 5x to the negative 1. So that's what f of x really means. Now, what can we do to simplify that? So I know that I've got 5, and then I've got 5 to the negative 1 power and x to the negative 1 power. So because this is in parentheses to the negative 1 power, both of those are raised to that power. And I know that 5 is going to be 1 over 5, properties of exponents. So 5 to the negative 1 becomes 1/5. And then x to the negative 1, a power to a power, you multiply powers. Negative 1 times negative 1 is just positive 1. So 5 times 1/5 is just 1. 1 times x is just x. So for this one, f of x is equal to x. And that's going to be for all real numbers except 0. 0 can't be part of the domain, or it would change the answer here. So let's say domain, all reals except 0. All right, and so for up here it says perform the indicated composition and state the domain. So I did state the domain for this one, but let's go back and state the domain for the first two. All right, so for this one, it's going to be all real numbers except whatever would make the denominator 0. So if this were 3 minus 3, that would not work. So this is going to be all reals except for 1. So all reals except x is not equal to 1. And I need to write that the same way over here. So x not equal to 0. All right, so basically how you find that, you do 3x minus 3 equals 0, add 3, then divide by 3, and that gives you what the excluded value is. So basically you're finding the 0 of the denominator. Remember, you can't divide by zeros, so you have to state that restriction in your domain. Right here, we're dividing by x. So again, it's going to be all real numbers except 0. 0 cannot be in the denominator. So all reals except x not equal to 0. All right, there's also another study tip here. G of 1 equals 0 is not in the domain of f because f of 0 equals 5 divided by 0, which is undefined. Okay, so that's basically talking about this right here. One of these functions, I don't know which ones it goes with, but anyways, it's talking about you not being able to divide by 0. So anytime you have a variable in the denominator, you have to state the restriction for what would make that 0. Whatever would make that 0, that would be the exception in the domain. That would create the restriction.